In 2017, astronomers detected something extraordinary, something that would shake the foundations of everything we thought we knew about our place in the universe. A strange, cigar-shaped object, unlike anything ever seen before, was hurtling through our solar system on a trajectory that screamed it didn't belong here. They called it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. But this wasn't just a cosmic curiosity. It was something far more unsettling, something that left scientists scrambling for answers and the rest of us wondering what it meant for humanity. Now, in 2025, groundbreaking new data has emerged, analyzed with cutting-edge techniques that peel back layers of mystery surrounding this interstellar visitor. The findings are nothing short of terrifying. This object, this so-called messenger, might not be a random piece of space rock at all. It could be evidence of something far more advanced, something that suggests we've been watched, studied, and perhaps even judged by an intelligence beyond our comprehension. Buckle up, because what's been uncovered will leave you questioning everything. Let's start at the beginning. When Oumuamua was first spotted by a powerful telescope in Hawaii, it was moving fast, too fast to be bound by our sun's gravity. Its hyperbolic trajectory meant it wasn't from our solar system. This was an interloper, a traveler from another star system, the first of its kind ever observed. Its shape was bizarre, roughly 400 meters long but only about 40 meters wide, giving it an extreme aspect ratio of 10:1, like a cosmic cigar or a flattened pancake, tumbling through space. Natural asteroids and comets in our solar system don't look like this. They're usually irregular, lumpy, or spherical, not elongated to such an extreme degree. But it wasn't just the shape that raised eyebrows. As it passed within 0.25 astronomical units of the Sun, closer than Mercury, it showed no signs of the behavior we expect from comets or asteroids. No ice, no dust, no comet tail, no outgassing, nothing. And then, something even stranger happened. It sped up, not chaotically, not randomly, but in a way that seemed deliberate, controlled, and precise. This wasn't the behavior of a natural object. This was something else entirely. What makes this acceleration so shocking is that it defies everything we know about how objects move in space. Comets, for example, can speed up when they approach a star due to outgassing, where solar heat vaporizes ice, creating jets that act like tiny rocket thrusters. But Oumuamua showed no such jets, not a trace of vapor, dust, or any material being ejected. Advanced quantum-enhanced optical modeling applied to the object's trajectory in 2025 revealed something astonishing. The acceleration wasn't random. It followed a mathematical pattern, perfectly counterbalancing the object's tumbling rotation. Every 7.3 hours, as it spun end over end, the acceleration adjusted by exactly the right amount to maintain its course. This is not how nature works. Comets don't self-correct their paths. Asteroids don't make micro-adjustments to stay on track. The precision of this movement suggests something designed, something engineered to navigate with purpose. But it gets even more mind-blowing. The new analysis uncovered microscopic variations in the acceleration that correspond precisely to the object's changing orientation relative to the Sun. These variations match theoretical models for advanced light sail technology, a propulsion system that uses stellar radiation pressure to move through space without fuel. Imagine a sail, not made of fabric, but of a material so advanced it can dynamically adjust its reflective properties to harness starlight, with pinpoint accuracy. This isn't science fiction. It's a concept we've only begun to explore in theoretical papers. Yet, the data suggests Oumuamua might be equipped with exactly this kind of technology. Its surface appears to adapt, shifting its properties to maintain stability while tumbling, something far beyond our current engineering capabilities. The implications are staggering. If this object is using a passive sail system, it could be designed to drift purposefully through interstellar space, propelled silently and efficiently by the stars themselves. This isn't just a rock. It's a marvel of engineering, one that makes our most advanced spacecraft look like toys. If you're as stunned by this as we are, stick around because the revelations only get more unsettling. The origin of Oumuamua is where things take a truly disturbing turn. Using data from the European Space Agency's Gaia mission, which has mapped over 1.8 billion stars with unprecedented precision, scientists traced the object's trajectory backward to its point of origin. What they found defies conventional astrophysics. Oumuamua came from a region known as the local standard of rest, a quiet part of our galaxy where stars move in relative harmony. But here's the kicker. This specific region lacks any of the cosmic mechanisms needed to naturally eject an object at interstellar speeds. Binary star systems, where two stars orbit each other, can sometimes slingshot material into space through gravitational chaos. Massive stars can blast debris outward with stellar winds or supernova explosions. But Oumuamua's origin point has none of these. No binary systems within 10 light years, no massive stars, no recent supernova, no star clusters with the dynamics to launch something at the velocity needed to escape its home system and reach ours. It's a gravitational dead zone, a cosmic backwater where nothing should be able to achieve the escape velocity required for interstellar travel. This raises a chilling question. How did Oumuamua get here? The absence of natural ejection mechanisms suggests it didn't leave its home system by accident. It's as if it was placed in this quiet region deliberately, launched from a point where its departure would attract minimal attention. If you wanted to send an object across the galaxy without drawing eyes to its origin, this would be the perfect spot. A stellar dead zone, where no one would suspect a launch. The data is clear. Oumuamua came from a place where it shouldn't have been able to leave on its own. This adds serious weight to the idea that it wasn't a natural wanderer, but something sent with intent. What do you think? Was this object placed in a cosmic blind spot to slip through the galaxy unnoticed? Let us know in the comments, and if you want to stay on top of this unfolding mystery, hit subscribe and turn on notifications. The universe is about to get a lot stranger. Now let's talk about the object's rotation, because this is where the story takes an even wilder turn. When Oumuamua was first observed, its brightness varied by a factor of 10 every 7.3 hours, suggesting it was tumbling chaotically like a broken top, spinning through space. That's what you'd expect from a natural object, irregularly shaped and drifting aimlessly. But in March 2025, researchers applied advanced deep learning algorithms to reanalyze the complete data set of its brightness variations. What they found was anything but chaotic. The rotation follows a complex but predictable mathematical sequence, a pattern so precise it's virtually impossible for a natural object to maintain over thousands or millions of years in space. The primary rotation cycle is exactly 7.3 hours, with a variance of less than 0.002%, a level of stability that defies the random impacts and gravitational tugs of interstellar travel. On top of that, there are microtational adjustments every 43.8 minutes, systematically exposing different parts of the object's surface to solar radiation. This isn't random tumbling. It's a deliberate, programmed pattern, like a spacecraft designed to optimize its functions. Engineers who study spacecraft design recognize something familiar in this pattern. It matches models for optimal energy collection, where controlled rotation ensures even temperature distribution and maximum exposure to stellar energy, much like solar panels on a satellite. But it's not just about energy. The rotation creates a scanning motion, as if the object was methodically surveying its surroundings as it passed through our solar system. It's the kind of behavior you'd expect from a probe designed to harvest energy, scan planets, or even broadcast signals in multiple directions. The AI analysis suggests this pattern was intentional, disguised to look random at first glance, but revealing its true purpose under scrutiny. This isn't a rock spinning aimlessly. It's something that was engineered to perform specific tasks as it traveled through our system. But the most perplexing discovery, the one that has scientists genuinely rattled, is what's been dubbed the thermal signature paradox. When the Spitzer Space Telescope turned its infrared detectors on Oumuamua in November 2017, scientists expected to see a clear heat signature. The object had just passed closer to the Sun than Mercury, where temperatures should have soared above 500 degrees Fahrenheit, 260 degrees Celsius. Any natural object, asteroid, comet, or otherwise, would absorb solar radiation and re-emit it as infrared energy. It's basic thermodynamics. Even the darkest asteroids show some thermal emission at that distance. But Oumuamua, nothing. Not a trace of infrared energy. The 2025 reanalysis, using enhanced thermal mapping algorithms, confirmed this anomaly. The object absorbed solar radiation, but somehow didn't re-emit it. This defies the laws of physics as we know them. No natural material can pull this off. Even Comet Borisov, another interstellar visitor in 2019, showed a clear infrared signature, exactly as expected. But Oumuamua was thermally invisible. There are only a few possible explanations, each more unsettling than the last. First, it could be made of a material with thermal insulation properties far beyond anything we've encountered in nature, an unknown substance that defies our understanding of physics. Second, it might incorporate metamaterials, engineered structures designed to manipulate electromagnetic radiation in ways ordinary materials can't. NASA has explored similar concepts for spacecraft shielding, but nothing close to this level of sophistication. The third possibility is the most disturbing: intentional thermal cloaking technology designed to hide the object's heat signature from detection. This aligns eerily with NASA's own research into stealth technologies for future probes, which aim to reduce thermal footprints. But even NASA's most advanced concepts can only reduce emissions, not eliminate them entirely, as Oumuamua did. If this was deliberate cloaking, it suggests a level of technology so advanced it was meant to slip through our solar system unnoticed. The question is, why? This brings us to a hypothesis that's gaining traction among leading scientists: the technological relic theory. What if Oumuamua isn't an active spacecraft, but a piece of technological debris, a remnant of an advanced civilization's exploration efforts? Its shape, resembling a damaged light sail or a communications array, supports this idea. The tumbling motion, while precise suggests a system no longer under active control, like a gyroscope that's lost some of its programming but still follows parts of its original design. The lack of emissions or transmissions points to non-functionality, as if it's a derelict probe, drifting silently through space. This ties into the litter hypothesis, a solution to the Fermi paradox that suggests the first evidence of extraterrestrial intelligence might not be a signal or a visitation, but technological garbage, scattered remains of ancient probes or spacecraft. It's a sobering thought. We've always imagined first contact as a grand moment, a deliberate encounter. But what if it's just cosmic junk, the leftovers of a civilization long gone, floating through our system? Yet, there's an even more chilling possibility. What if Oumuamua isn't debris at all, but a dormant probe, one that's already completed its mission? Imagine an advanced civilization sending thousands of small, efficient probes across the galaxy, designed to observe star systems, collect data, and then go silent, blending into the cosmic background. Oumuamua's trajectory was perfect for this. It passed through the information-rich inner solar system, close enough to scan Earth and the inner planets, but far enough to avoid easy detection. Its acceleration, as it left the Sun, could have been the final phase of its mission, a burst of speed to exit our system after gathering what it needed. If it was a surveillance probe, it might have already transmitted everything it learned about us, our technology, our atmosphere, our communications, back to its point of origin. We'd never know, because we weren't looking for it until it was already on its way out. This leads to the most alarming theory yet, the passive probe hypothesis. What if Oumuamua was a fully functional surveillance device designed to observe without being detected? Its trajectory was remarkably efficient for reconnaissance, threading through our solar system in a way that maximized data collection while minimizing exposure. It passed through regions ideal for picking up our global communications, television, radio, internet, for about 72 hours during its closest approach to Earth. Its thermal invisibility, precise acceleration, and patterned rotation all point to stealth technology optimized for observation. A passive probe like this wouldn't need to transmit signals or approach planets directly, which could risk detection. Instead, it would quietly listen, record, and move on. It could have analyzed our atmosphere for biosignatures, measured our electromagnetic emissions to gauge our technological level, and catalogued our resources. If this is true, we've been studied, evaluated, and possibly catalogued by an intelligence we know nothing about. The implications are profound and unsettling. If Oumuamua was a probe, it's already sent its findings back to wherever it came from. We've been observed and we're none the wiser. The asymmetry is terrifying. They know about us, but we know almost nothing about them. Historical precedents don't exactly inspire confidence. Reconnaissance often precedes more direct contact, and not always with peaceful intentions. If this was a scout, what comes next? A closer visit? A larger probe? Something more direct? And here's the kicker. We only detected Oumuamua by chance. Our telescopes caught it during a brief 10-day window as it passed through our system. How many other objects like this have slipped through unnoticed? Statistical models based on our detection capabilities suggest at least one such object passes through our inner solar system every year. Most are invisible to us, hidden by the sun's glare or our limited sky coverage. The Vera Rubin Observatory, set to begin full operations in late 2025, could change that. Its massive 8.4-meter mirror and 3,200 megapixel camera will scan the entire visible sky every 3 nights, potentially spotting interstellar objects weeks or months before they reach us. This could give us a chance to intercept one. Project Lyra, a mission concept from the Initiative for Interstellar Studies, proposes launching a spacecraft to catch up with an object like Oumuamua. Using a Jupiter gravity assist and advanced propulsion, it's theoretically possible to reach one within 2 to 3 years. But the challenge is immense, requiring 5 to 6 times the energy of a Mars mission. If we succeed, we could finally get a close look at one of these visitors. But what if it's not just a relic or a passive probe? What if the next one slows down, approaches Earth, or tries to make contact? The technology we've inferred from Oumuamua, light sails, thermal cloaking, precision rotation, suggests a civilization far beyond our own. If their intentions aren't peaceful, we'd be powerless to stop them. As we grapple with these questions, the 2025 data forces us to confront a reality we're not ready for. This isn't speculation or science fiction. It's hard evidence, drawn from rigorous analysis by leading institutions using our most advanced tools. The acceleration wasn't random. It matched a light sail model with mathematical precision. The origin point, a stellar dead zone, makes no sense for a natural object, but is ideal for a covert launch. The thermal invisibility defies physics as we know it, pointing to metamaterials or stealth technology. The rotation pattern, uncovered by AI, suggests a designed object scanning its surroundings. The extreme shape, the lack of emissions, the deliberate trajectory, all scream artificiality. This isn't just a rock or a comet. It's a technological signature we can't ignore. Oumuamua is gone now, speeding away on its hyperbolic path, never to return. We had a fleeting chance to study it, and we weren't prepared. But its legacy is a wake-up call. It's forced us to rethink our place in the cosmos, to question whether we're alone, and to wonder if we've already been found. If it was a probe, it knows more about us than we'll ever know about it. It may have catalogued our world, our technology, our vulnerabilities, and sent that data to an unknown destination. And the most terrifying thought of all? It might not be the last. Statistical models suggest more are coming, slipping through our system every year, unseen, undetected, until now. The next one could be closer, bolder, or more direct. Are we ready for what comes next? For a quick recap, here's what we know for sure. Oumuamua was discovered on October 19, 2017, by the Pan-STARRS telescope in Hawaii. Its name, meaning a messenger from afar arriving first, feels eerily prophetic. It's about 400 meters long, 40 meters wide, with an aspect ratio unlike any natural object in our solar system. It rotates every 7.3 hours, causing its brightness to vary dramatically. It showed no comet tail, no ice, no dust, despite passing closer to the Sun than Mercury. Competing natural explanations, like a nitrogen or hydrogen iceberg, have been proposed, but they struggle to account for all its anomalies, especially the precise acceleration and thermal invisibility. The 2025 data has only deepened the mystery, suggesting a level of technology that challenges everything we thought possible. This discovery is just the beginning. The universe is full of enigmas, and Oumuamua has shown us how little we truly know. If you're as gripped by this as we are, subscribe and hit the notification bell. We're digging into more cosmic mysteries, breaking down revelations that mainstream science often overlooks. The truth is out there, and it's more terrifying and exhilarating than we ever imagined. What do you think Oumuamua really was? A natural oddity, a derelict probe, or something actively watching us? Drop your thoughts in the comments, and let's keep this conversation going. The next cosmic visitor could already be on its way,